Hello, welcome to your last lesson on statistical test. Chi-squared is the last one that we're going to look at. So, as always, have your textbook, your pen and paper ready. This is your starter. So just read through the question, A and B, have a go at answering, and then we'll go through the answer together. So with A, it should be pretty straightforward because it tells you in the scenario whether it is directional or non-directional. And with B, just remember, it's not asking you to conclude the findings, it's just asking you to say whether it's significant and why it's significant or not significant. So mark your answer now. For A, you get 1 mark if you said that it was directional, because the psychologist said that memory would be impaired with a restricted diet. So it told us which way the results were going to go, so therefore it's directional. And then for B, you get 1 mark for correctly stating that the result is significant. And the 2 extra marks is for your explanation. So you had to write the calculated value, which was 53, and state that it's less than the value of 60, which is the critical value, where n is 20 because that's the number of participants, and the significance level was 0.05, and we were doing a one-tail test because it was directional hypothesis. Last lesson I asked you to do this apply your knowledge question. So if you need to pause me to go grab your answer for this, feel free. We're going to go through the answer now. So A asked you to identify a suitable test to use this data and justify your choice. So in this case, out of the 2 that we looked at for test of association, it would be Spearman's row, because Pearson's R only test inter-rater reliability, which is not what we're doing here. So you should have written something along the lines of a suitable test would be Spearman's row. This is because the study is testing for an association between 2 covariables, age and GCSE grade, and the level of measurement is ordinal. You may have got confused and thought that it was interval because of the age, but if one of the covariables is ordinal, you can't do an interval test on it. So you wouldn't be able to do Pearson's R because GCSE grade is not interval, because the differences between the grades are not at fixed intervals. And then B, the researcher calculates the correlation coefficient for 15 participants. So already you should be looking at n is 15. Using a non-directional hypothesis, what calculated value would be significant at the 2% level? So you needed to look at 15 and the 0.2, so the critical value for this test was 0.521. So then you should have said something along the lines of, at p is less than or equal to 0.02, anything equal to or greater than 0.521 would give a significant result. Remember, Spearman's row has an R in it, therefore the calculated value has to be greater than the critical value. Quick reminder on something that we looked at in gender bias, because it's going to help us when we do this chi-squared test. So if you remember, we talked about this piece of research by Kohlberg, who found that moral decisions we make are based on an ethic of justice. Now, the way that he found this out was he asked boys and men what behaviours would be right in certain situations relating to fairness. And then he concluded that everybody makes moral decisions based on an ethic of justice. So why is this an example of a beta bias? Pause me now and just have a think about that. So beta bias is when we ignore or minimise the differences between gender or cultures. So Kohlberg did this by assuming that the research done on only men and boys would apply to females. Gilligan did a study based on Kohlberg's theory, and she found that women favoured a care orientation while men favoured a justice orientation. And she went on to argue that Kohlberg's theory actually led to an alpha bias because it made women seem less moral than males. Whereas Gilligan's theory demonstrates universality because it showed that men and women are different, but it wasn't biased because she didn't state that any kind of moral reasoning was considered better than the other. She just said that they were different. Okay, so as I've mentioned, today we're going to be looking at chi-squared. So chi-squared is a bit of a weird one because it can be used to test difference, and it can also be used to test association. It's also one of the very few tests that deal with nominal data. So for each category that you count up, the number of people or items in that category would be considered. And these data, if we're testing for difference, are unrelated. In other words, no person or item can appear in more than one of the cells. So it's only done when it's an independent group's design. The investigation we're going to look at today for our chi-squared is from Gilligan and Antonucci, who found that women were more likely to make moral decisions based on an ethic of care and men made decisions based on an ethic of justice. So step one in a chi-squared test is again to state the hypotheses. So because it can be a test of difference and association, you need to state both sorts of hypotheses. So the alternative hypothesis stating that there will be a difference, the alternative hypothesis stating that there will be an association or that there won't be an association, would be your null hypothesis. So you need to be writing 3 hypotheses for this. This is going to be written as a non-directional or a two-tailed hypothesis. So you should have written, number 1, there is an association between gender and the kind of moral decisions made. So it's non-directional because it's not telling us which way it's going to go, whether women are going to base their moral decisions on an ethic of care or an ethic of justice. It's just telling us that there will be an association between moral decisions and gender. And then there is a difference between men and women in terms of the basis for making moral decisions, which would be your test of difference hypothesis. And then the null hypothesis would be there is no association/difference between men and women in terms of the basis for making moral decisions. So why are we choosing a chi-squared for this investigation? It's a test of association and a test of difference. With the test of difference, it's an unrelated design because men and women would have to be independent groups. And the data is nominal because it's just going to state what categories they are, whether they are male or female, and whether they base their moral decisions on an ethic of care or an ethic of justice. So therefore, we're going to be looking at chi-squared. Step 2. In a chi-squared, we place the raw data in something that we call a contingency table. So you have it's usually 2x2 contingency table, but it can also be 3x2, etc. So in this case, we have male and female at the top, ethic of justice, ethic of care at the side, and then we've just tallied up the frequency that each of those occur. So in the female, 5 of them based their moral decisions on an ethic of justice, and 10 of them based their moral decisions on an ethic of care. And then for males, 12 of them based their moral decisions on an ethic of justice, and 9 of them based it on an ethic of care. And then all you've done is worked out the totals. The contingency table would usually be written up for you, but I have seen exam questions in the past where they've asked you to draw a contingency table. So then you just have to work out the totals as well, but they'd usually give you the results for this. Step 3 is to find our calculated value. We want to find chi-squared. This looks very complicated, but I'm going to break it down for you and hopefully you will understand. And you can see that all the cells, all the main cells, have been labelled A, B, C and D. And in this table here, we work through each cell at a time. So let's start with cell A. What we do is we find the total number of people who base their moral decisions on ethic of justice, which is 17, and we times that by the total number of females. So that's how we get 17 times 15. Then we divide it by 36 because that's the total number of all participants. And we get this expected frequency of 7.08. So then what we want to do is E minus O. So we subtract E from the observed value. The observed value is 5, and that gives us 2.08. It doesn't matter which way you do it, because what we do with this section is we ignore all of the minuses. So obviously you know that 5 minus 7.08 is actually minus 2.08, but we ignore all of the minuses. So we would just put 2.08 instead of minus. And then we square the this number, 2.08, to get 4.3264. And once we've got this value, then all we do is we divide it by E again. In this case, E is 7.08. So that gives us a total of 0.6110. Let's go again with cell B. So cell B is here. So we need 17 times 21, because that's the total number of males, divided by 36, again, the total number of participants. That gives us an E value of 9.92. We take the observed value, so what we actually found, and we subtract the E value from that, and it gives us 2.08. So again, the square of the previous value is going to be the same, and then divide that number by 9.92 to get this value. Cell C here, so we take 19 and 15, times them together, divide them by 36, we get 7.92. We subtract that from the observed value of 10, which gives us 2.08, square that, and then divide it by 7.92. And then finally, cell D, we take 19 times 21 divided by 36, which gives us 11.08. We subtract 11.08, our E value, from our observed value, which in cell D was 9, and we get 2.08. Square that, and then divide it by 11.08. And then all we do is we add all of these up to get 1.984. So this value is actually incorrect in your book, so just follow this PowerPoint instead of the values in the book, because in the book it shows this as 1.3905, which is incorrect. So you'll never be expected to remember all of these steps in the exam. You don't have to memorize that, but there's no reason why they wouldn't ask you to input some of the numbers. So they might have, for example, and then as always we find the critical value, and with chi-squared we look at degrees of freedom. So our significance level is 5%, so 0.05. We did a two-tail test because our hypothesis was non-directional. So we're looking at this section here. The degrees of freedom value is the number of rows minus 1, which was 1, because the number of rows was 2, because we had justice and care. So -1 from that gives us 1. And then the number of columns, we also had 2, because we had male and female. So 2 minus 1 is 1 again. 1 times 1 is 1. So our degrees of freedom value is 1. So therefore our critical value is 3.84. And the calculated value has to be greater than the critical value for it to be significant, because chi-squared has an r in it. So therefore calculated has to be greater than critical. So then we just state the conclusion. Our calculated value, just to remind you, was 1.984. Our critical value was 3.84. Is this significant? No, it is not, because the calculated value is not equal to or greater than the critical value. So then we state our results like this. As the calculated value is not significant at p is less than or equal to 0.05, we must accept our null hypothesis and conclude that there is no association between men and women in terms of the basis for making moral decisions. And that would be your conclusion. And this is something that you could be asked to do in the exam. So that's it for today. All you have left to do is a 13 marker, which I have attached to this lesson. So have a go at that, and I will be uploading the mark scheme next week so you can mark your answers from there. Any questions, please let me know, and upload your notes onto Teams. Thank you.